All right, if you're getting ready for your GCSE chemistry exams, you are in exactly the right place. Today, we're going to crack the case of identifying ions. We'll break down all the key tests you have to know, making them super simple and easy to remember so you can walk into that exam feeling totally on top of it. So here's our game plan. We'll start by opening up our detective's toolkit. Then we'll go on the hunt for those positive cations and the negative anions. After that, we'll briefly see how the experts do it with modern methods, and we'll finish up with a super fast summary to make sure it all sticks. Okay, let's jump right in. Picture this. You're in the lab, and you get handed a test tube. Inside is a clear, unknown ionic compound. It's a total chemical mystery. Your mission, should you choose to accept it, is to become a chemical detective and figure out what's inside.
Now, every good detective needs a toolkit, right? Well, in chemistry, our toolkit is a specific set of chemical tests. Think of each test as a way to get a clue. It might be a color change, maybe some fizzing, or a solid appearing out of nowhere. Each clue helps us to identify our chemical suspects.
Our investigation always starts with the cations. Those are the positive metal ions. And the good news is, these guys often leave behind some really obvious clues. I'm talking bright, dramatic colors. And our first tool for this job is one of the coolest looking tests in chemistry. It's called the flame test. And honestly, it's pretty much what it sounds like. You take a little bit of your compound, you stick it in a flame, and the metal ion inside burns with its own unique signature color. It's basically like a firework fingerprint for that specific metal. Okay, you're going to want to really focus here, because these 5 are must-knows for your exam. If you see a deep crimson red flame, you've got lithium. A really intense, bright yellow, kind of like a streetlight, that's definitely sodium. Potassium gives off this beautiful lilac color. Calcium is an orange red. And copper, well, that's a brilliant green flame. You got to lock these 5 into your memory. But, a good detective always thinks about the limitations of their tools. For example, that super bright yellow from sodium, it can easily overpower and hide the much more delicate lilac color of potassium if they're mixed together. So what do you do if the flame test doesn't give you a clear answer? Well, we just reach for another tool. And our next tool is the precipitate test. What we do here is add another chemical, sodium hydroxide solution, to our unknown sample. Now, if certain metal ions are in there, they'll react and form a solid that, well, it just falls right out of the solution. That solid is called a precipitate, and its color is our next big clue. And the process couldn't be simpler, really. You take your sample, you add just a few drops of sodium hydroxide, and then you watch. You're looking for a solid to form, and you're paying really close attention to what color it is. And the results can be so clear. If a bright blue solid appears, bam, you found copper ions. If you get a kind of sludgy green precipitate, that's your sign for iron 2. And if you see a reddish-brown, almost rusty-looking solid, that's the classic fingerprint of iron 3. These are easy marks in an exam if you just remember those colors. But of course, the case isn't always so straightforward. Sometimes you add your sodium hydroxide and you just get a plain white precipitate. Now that's a puzzle because 3 of our main suspects, aluminum, calcium, and magnesium, all do this. So how on earth do we tell them apart? We need one last deciding clue. And here it is. This is the crucial step. After that white solid has formed, you keep going. You add excess sodium hydroxide. If that white precipitate disappears, it redissolves and the solution goes clear again, you have definitively found aluminum. If the white solid stays put, it's either calcium or magnesium. This little detail is a classic exam question, so don't forget it. All right, detective. Case half solved. We found our positive cation. But every ionic compound needs a partner in crime, the negative anion. So now our investigation flips, and we start hunting for these nonmetal ions. First suspect, the carbonate ion. This is a 2-part test. First, you add a simple dilute acid. If you see fizzing, what we call effervescence, that's your first clue. That gas is probably carbon dioxide. But to be sure, you have to prove it. You bubble that gas through some lime water, and if the lime water turns milky or cloudy, case closed. You've found a carbonate. Next up, we're on the hunt for the halides. That's chloride, bromide, and iodide. For these, you first add some dilute nitric acid. That's just to get rid of any other ions that might mess up our results. Then, you add silver nitrate solution. And just like before, you look for a precipitate. A white one means you've got chloride,
A cream-colored one points to bromide, and a pale yellow precipitate is the telltale sign of iodide. And our final anion to track down is the sulfate ion. It's a similar process. First, we add an acid, this time hydrochloric acid. Again, just to clean up the sample. Then we add some barium chloride solution. If there are any sulfate ions in there, you will immediately see a thick, white precipitate form. It's a really solid, reliable test. So there you have it. That's all the classic test tube chemistry you'll need for your exam. But just for a moment, let's peek into how modern science labs do this stuff, because they often use powerful machines instead, and it's useful to know why. Really, it all comes down to three things: accuracy, sensitivity, and speed. The tests we've learned are great, but these instruments are incredibly accurate. They're also extremely sensitive, so they can detect even the tiniest trace of a substance. And they're super rapid. They can get a result in seconds. The specific example you should know about is flame emission spectroscopy. The easiest way to think of it is as a superpowered version of our flame test. The machine still puts the sample in a flame, but then it uses a detector to analyze the exact wavelengths of light being given off. This means it can identify the ion with 100% certainty and even tell you exactly how much of it is there. Okay, we have gathered all the clues and all the evidence. So before we finish, let's file our final case report. Here's a quick-fire summary of everything you need to lock in for that exam. Okay, for the cations, the positive ions, you need your 5 flame test colors: lithium crimson, sodium yellow, potassium lilac, calcium orange-red, and copper green. Then for the sodium hydroxide test, remember your 3 colored precipitates: blue, green, brown, and the 3 white ones, remembering that special extra step for aluminum. And for the anions, the negative ones: carbonates, that's acid plus lime water; halides, nitric acid, then silver nitrate for a white, cream, or yellow result; and sulfates, hydrochloric acid, then barium chloride for that dense white precipitate. Got it? And that's the whole toolkit. It might seem like a lot, but by mastering just these few simple tests, you're now fully equipped to identify dozens of different ionic compounds that could pop up on your exam paper. That's a pretty powerful set of skills for any chemical detective to have. So there you go. You now have the complete detective's toolkit. The methods are clear, the clues are unforgettable, and you are ready. Now go out there and solve those chemical mysteries. Good luck with your revision.